In today's video, I want to look at mathematical modelling and constructing functions. This is basically the chapter that looks at word problems. And I know word problems normally aren't people's favourite, but there are a ton of examples in the textbook that I highly encourage you to go ahead and look through. I've picked 3 of them here to go through, but like I said, there's a ton more in the textbook. So go to chapter 6 in the textbook and go and you can follow through exactly what I'm doing with these 3 and look at the additional examples that we have. Whenever you come across a word problem, there's a couple things that I want you to always do. First thing is anything that you don't know, so any kind of unknown that you have, assign a variable to it. So if you have the side of something that you don't know the length of, if you have, I don't know, a distance that you don't yet know, assign a variable to it. Okay, so first thing, always assign a variable to any unknowns. That will help you when you go ahead and do the algebra in these problems. Second thing I want you to 100% always do, and this is the most important point, always draw a picture if you can. So whenever they give you these problems, just sketch out a quick drawing of what's happening, and it will help you so much as you go ahead and try to visualize exactly what is happening in the problem, and it will really help you to solve it. So the second point to always do this 100% is to draw a picture of the problem. Like I said, I'm going to pick 3 problems here from the textbook and run through them, but there are many more examples in the textbook, but you can follow along with these as we go through it. So, our first example, we're looking at these 2 cars that are moving towards an intersection, towards each other. So they're going towards this same intersection that's here. Okay. And the question is, express the distance, that straight line distance between them, as a function of time. Okay, well, at the start of this problem, we can see that there is 3 miles distance between the intersection and the first car, and 2 miles of distance between the intersection and that second car. First car's moving towards the intersection at 40 miles per hour, second car's moving towards the intersection at 30 miles per hour. Okay. This is where you have to know a very small formula that you probably learned in physics, and that is the speed, distance, and time formula. Okay? Distance is speed times time. Okay? So if I want to figure out this distance here, so the distance between the first car at the intersection at any time t, we start off at being a 3 mile distance between the car and the intersection at time 0. It then moves closer and closer and closer to the intersection. Okay? The distance that it travels is going to be the speed it's doing, which is 40 miles per hour, multiplied by the time. So the distance it has travelled is 40 times the time in whatever time it has taken to do that distance. So as it's moving towards the intersection, that distance is going to be the 3 miles that it started out at, minus, as it's getting closer, it's going to be minus the 40 miles per hour times the time, okay? Because the distance is the speed multiplied by the time taken. And as it's moving towards the intersection, it means that distance is getting smaller, so I'm doing 3 minus that distance. Okay? Same happens here. Okay, I start out with a 2 mile difference between the intersection and the car. Car's moving at 30 miles per hour. So because I start out with a 2 mile distance, I'm going to have 2 minus the speed that the car is doing multiplied by the time. So the distance that the car has travelled in some time t is 30 multiplied by the time. But I want to know the distance from the intersection to the car. which is going to be the 2 miles that we started out at, and as the car is moving closer, that distance is going to shrink. So it's the 2 miles minus the distance that the car has travelled at time t, which is minus 30t. Okay. Now we've got to express that distance, that straight line distance d, as a function of time. I have 3 distances here. I've got my straight line distance, then I've got the distance of the first car to the intersection and the distance of the second car to the intersection. You should see here I have a right triangle. So I can go ahead and use the right triangle formula in order to find that distance d. Okay? This tells me d squared is going to equal 3 minus 40t squared plus 2 minus 30t squared. Okay, remember a squared plus b squared equals c squared when you do a right triangle. So the 2 other sides, the straight line sides here, if you square each one of those, add them together, it should equal the square of that diagonal side. Okay. So to find d in terms of t, all we have to do is to take the positive square root of both sides. And that gives me my distance in terms of my time. Okay. The next problem we have is a carpet problem. So in this problem, there is a carpet maker and he has said, okay, I need to trim this carpet down in order for it to fit a particular room. Okay. So what he has done is he's taken a carpet that is x feet long and x feet wide, so it's a square carpet, and he wants to know, okay, if I trim off 2 feet from each side, so 2 feet from every single side, and then 3 additional feet from every single side, what is the area of the carpet that I am left with in terms of my original length and width x? Okay. Now the big thing with this problem is, and this is why I would always draw something like this out, just like we have here. Remember, he has taken 2 feet from every side and then 3 feet from every side. So when you draw this, make sure that you do apply that to every single side. If we look at this, so let's take this side x, okay? So this is x feet. I've taken 2 feet away top and bottom. So this length here should be x minus 4 because I've taken 2 feet away from the top, 2 feet away from the bottom. Okay, we're going to apply that again to find this length here. Okay, I've now taken 3 feet away from the top and 3 feet away from the bottom. So I've got to subtract an additional 6 feet away from my width, which will give me x minus 10. Okay. Same happens with the bottom here. Remember, you've got a square carpet and you're actually taking away the same from each side. So you start off with a length of x, then you've subtracted 2 feet from either side. Okay, so this side here is going to end up with a length of x minus 4. And then here, this side here, I have now subtracted 3 feet from each side again. So now I end up with x minus 10. So my final carpet is x minus 10 by x minus 10. So the area in terms of x is going to be x minus 10 squared. So this is why I would always draw it out, to make sure that you have taken 2 feet from every single side and then the additional 3 feet from every single side. And that would be in square feet. Okay. You can do an additional part of this problem. And the question could be, how many square feet were removed from the first trim job that you did? So basically I'm asking, what is the area of this red shaded area. How many square feet were removed in your first trim job? Okay. The way that I would go about this is to look at what the area of my original carpet was, and then look at the area of the carpet that I have left and subtract one from the other. So the area of my original carpet is x squared. Once I've done that first trim job, my carpet is x minus 4 by x minus 4. Okay. That means that the area that we had trimmed, so the area that we have taken away, the area of that red section there, would be the original minus what I'm left with. Okay. If you wanted to, you could simplify this and say that that's x squared minus 8x plus 16, which would leave you with 8x minus 16. And again, that would be in square feet. The final problem I want to look at, this is a slightly more difficult problem, but once you kind of see where it's heading, it's not so bad, but this is a more challenging problem. It states that we have 10 meters of wire, and it's used to make both a square and a circle. So we've taken a piece of wire, we've cut it in two. With one piece of the 10-meter wire, we've made a square, and with the other piece of the 10-meter wire, we have made a circle. And the question is to find the area of both shapes combined, but do that area in terms of x. So I basically want to get rid of this r variable in my area equation. So I know that the area of the square is just going to be length times width, give me x squared. The area of a circle is pi r squared. Okay? That's not in terms of x yet, and we want to find our area in terms of this x value. Another formula I can actually look at to try and transform this r into something in terms of x is by using the circumference. Okay, I know that the perimeter of my square is 4x. The perimeter of a circle is 2 pi r. Okay, I know that that perimeter, that 2 pi r, is going to be my original length of wire minus however much I used of it to make the square. So my perimeter of my circle must be however much wire I started with minus however much I used here. Okay, so the circumference of the circle, the amount of wire used for the circle, must be the 10 meters that I started with minus however much I used for my square. I can now rearrange this and divide both sides by 2 pi, and that should give me r is equal to 10 minus 4x over 2 pi. That gives me r just in terms of constants and x, which is exactly what I want. So now to find my area, I can say that the area in terms of x, so the area of the two shapes put together, is going to be the area of the square plus pi r squared. But now I have r in terms of x, which is x squared plus pi multiplied by 10 minus 4x over 2 pi all squared. You can, if you want to, simplify this. That is totally fine. If you square a fraction, you square the top, square the bottom. you would actually end up with 1 pi on the denominator cancelling out with the pi that is here, and your solution would then be x squared plus 10 minus 4x squared over 4 times pi. If you did want to simplify it, that is totally up to you. But here you can see what we have done. We have assigned the square, the unknown side, a variable x. And then we have tried to find the area of everything put together in terms of that one variable. I had a variable, my radius, that I did not know what it was in terms of x, but I used another formula, being the circumference of a circle and the perimeter of a square, in order to find that radius in terms of x. And then I could go ahead and write everything in terms of my unknown x. So it may take some work here and there, and it may involve using some formulas that maybe you haven't seen in a while, but there shouldn't be anything in here that shocks you that you've never seen. Okay. If you do have any questions on these or any of the others in the textbook, please feel free to ask me any questions, but I highly recommend you just go ahead and read through those ones in the textbook just to make yourselves familiar with some of these word problems.